Hello everyone. In this video, we are going to learn about the spline command in sketching of SolidWorks. So let's start. Spline is a very advanced tool, like how we are going to make the spline in the sketching and how to use it. So I would request you to see this tutorial with all the focus because it needs your full attention as the spline is an advanced tool along with you get a lot of options in this spline. So let's zoom in here and you can see this is the spline which is getting drawn in the window. So now let's start. Just click on spline. We have to select the plane and here comes the spline tool. Just make it normal. Now I can make this spline like this. Press escape once you're finished. So this is the basics, like how to draw this spline with using the command. Now comes the advanced part. So currently I'm going to cover whatever is getting displayed on my graphics window. So you can see there are 4 points. Let's calculate with me 1, 2, 3 and 4. Okay, so that means there are 4 control points. These points are said to be as control point. And whenever we click on this spline, it will highlight all the related control to that spline. Like these vectors are going to display the length of this spline, like here. This is the straightness, like how much straight portion is going to be get covered in this spline. Next thing is regarding the angle, like this. So these two things are getting controlled by these arrows, or you can say as vectors. Okay, now just leave them like this. Now the very first thing regarding these control points is dimensioning, like how we are going to give the dimensions. So I'm going to delete this. Now again go to this spline and make a spline once again. Press the escape key. I need a center line here just for the reference. So I will make a center line like this and give the relation as horizontal so that it would not change its position in terms of angle. Okay, because we need the angle also in the case of controlling the control points of spline. Now let's start dimensioning them. Just go to the smart dimension and click on the point on which you want to give the dimension. So I want to give the dimension here, and then we have to click here for the straight portion, like how much it is going to travel in this direction. So I want more length. Just enter the higher value like 100, and along with that, now this portion has been controlled. If I just press escape key, now you can see I cannot move in this direction like here, but here is free. Like you can see the movement is free here. So I want to lock this movement. So to lock this movement, we have to give the angle with the horizontal. So let's go to the dimension again. We have to click here, hold the control key and then select the center line. And here you can give the angle. Now you can see this is blacked out, and blacked out means fully defined. Now press escape key. Now you can see we cannot move in this direction. Along with that, we cannot change the angle like this. So it is locked. However, this is free, this point, and we can increase or decrease. Okay, just press the undo as I have disturbed it. So as we can increase or decrease, along with that we have the angle control also, like this here and like here. But we cannot disturb, but as you can see, we cannot do anything about this, like about these vectors. Okay, so let's control this point. To control this, I'm just giving the demonstration again. We have to just click here for the one time now and just leave it here, and I'm going to give the straightness here as 200. Okay, now the next part is regarding the angle. So the angle is going to be like this. This is going to be as 4. I'm going to just rearrange this. Now this is how you can give the dimension regarding the angle along with the direction, like how much it is going to have the straight portion regarding this. So this is how you have to give the dimension, and I hope you can fully define this sketch by using the dimension tool. Okay, so this is the regarding whatever is getting displayed on the graphics window. Now what is not getting displayed, let's do talk about that. Just go to the spline again, and here I'm going to make a spline again like this. Now we have talked about like what is getting displayed on the graphics window, and we have seen the entire dimensioning regarding those points. Now what is not getting displayed, let's do uncover that. Just do the right click here, and here comes the very first option, which is insert spline point. And we are familiar with like what is spline point. These points are said to be as spline points, or you can say as control points. So I'm going to insert a spline point like here. Wherever you click, it will insert a spline point there. More the spline points, more will be the control on the spline. Okay. So now you can see I have added 3 to 4 more spline points on the same spline. Now undo this so that all the added spline point could get disappeared. So this is the initial condition. Now let's have some more options. Just do the right click, and here comes the option of show minimum radius. Like here, if I just zoom in, if someone wants to have the details on like what is the minimum radius the spline holds, so you just have to click on that and it will represent that this is the minimum radius. Now in some cases the user have to be concerned about the minimum radius, as there are some bands which needs to be get followed as per the documents. Like we have the minimum radius should be more than 3D. 3D means whatever the cable diameter, that the path of that cable should have the minimum radius which is more than 3D. So if the diameter is 10, so the minimum radius should be more than 3D. That means minimum radius should be 3 into 10, which is 30 mm. Okay, if we talk about the MMGS system. So that's why we need the minimum radius tool here. Now here comes the display control polygon. Like if I have just clicked that option, which option? Display control polygon. Okay, now you can see this is the control polygon, and I can control the same spline from these points as well. Like you can see here, and you can see wherever the minimum radius occurs, it will change its position. Like you can see from right hand side to the left hand side, and then again back to the right hand side. So you can see the magic is happening here on the graphics window, which was hidden. That's why I have said to you that what is not hidden, what is not showing on the graphics window, we will talk later on after what is getting displayed on the graphics window. So these are some advancements regarding these splines, like how to insert the spline point, how to display the minimum radius, how to display the control polygons, and show spline handles. These were the spline handles. You can also show from this show spline handles. Okay, so this is the what we are getting. Okay, now if we to talk about the simplify spline, like what is the meaning of simplify spline? Simplify spline, if you just click on this, so in here you can see here in original curve there are 6 control points: 1, 2, 3, 4, 5, 6. Okay, now it is asking us for the tolerance, that by what tolerance you want to make it smooth. So if I just click on smooth, make it more smooth, make it more smooth, so the tolerance will keep on increasing, increasing and increasing. So I'm going to make it more smooth, and just click on OK. So Here comes the pop-up. Some spline handles and all equal curvature relations will be deleted. Continue anyway. Of course, because this is a demonstration part. So I have continued and here comes only 2 points along with these handles. So this is how we can use the simplify tool for the spline. Like if I just right click here and just go to the which option? Simplify spline. So currently that is not getting displayed here because this is already simplified. So this is just for the demonstration like how to simplify the splines along with the tolerance and along with how you can make it smooth. So this is the general demonstration regarding spline along with some advanced tricks. I'm going to delete it now. Now comes the second part, which is style spline. So let me place the spline here at the origin. Just press the escape key. Now I'm going to make a center line here. Just I'm going to give the direction as 50 and this is going to be 150. Okay. I'm placing this just for the comparison purpose. Make it horizontal. Now let's go to the style spline. Here comes four option. Bezier, B-spline. B means bezier, so bezier spline. Degree 3, degree 5 and degree 7. More the degree, more will be the smoothness. Okay. So just cancel this because I want to offset them first. So I'm going to have some offsets here of 50. We will cover the offset but in the later tutorials. Okay. So this is going to be 50, but I need this to be in construction mode. Again, I'm going to have this offset entities and this is going to be 50 again minus 50. I'm just making it very basic so that you could understand like how these splines are going to work. Okay, now let's extend this using the advanced tool of extend. Now just hold the left mouse button and leave the left mouse button here. Okay, so this is how we can use the extend in the single go. Now let's understand the differences among the different kinds of spline. Like this is the simple spline, and if I just go to the style spline, this is the bezier spline, the very first one. So I'm going to make a spline like this. Now just going to press the escape. This is the bezier. Okay, the very first one. Next, we have the bezier spline with degree 3. So I'm going to have this like this. Press escape. Now again go to the same and we will have the degree as 7. I'm skipping this degree as 5 because I want to show you something. Now press escape. So if I just talk about the smoothness, you can see this is more smooth than this and then this. This is the smoothest one. So higher the degree, higher the smoothness. This will appear like this if I just have this, drag this down like this. And this one also like this. And this one also like this. So you can see there is a slight difference among these curvatures, like this goes like this and this goes like this. This is more smooth, having the more tangency just because of the degree. So this is the basic difference regarding the splines, and this option of style spline. This is going to be used in the advanced sketching, like if you are going to deal with the deep surfacing somewhere we have to trace the surface of shapes. So there we use the B splines because they are easier to control. Okay. So now let's do talk about the next option, which is equation driven curve. I hope both these options in the splines are clear to you. Like we have discussed about this spline, how to make this spline, how to insert this spline, how to show the minimum radius, along with we have come to know about the dimensioning of this spline, angle, and the length of the handle. Along with that, we have covered the style spline where we have discussed about the bezier and some common differences among them. Next comes the magic. Here is a very fine tool regarding the equation driven curve. So for that, I'm just going to clear the graphics window, just like this, and I'm going to delete this. I'm going to delete this one, and this one. Now directly go to the equation driven curve. Here comes the two options, which are explicit and parametric. So let's do talk about the explicit. In the explicit, we have to enter an equation in terms of x here. We have to enter an equation in terms of x. Okay, like we have the parabolic equation as y square equals to 4ax. So we will have the example of the parabola also, but first let's understand how the equation is going to work here and what are the operators. So if I just talk about the operator, so the very first operator is plus. Just let me have this plus. Then second operator is minus. Okay, so this is very important. Please do not get confused. Like in some cases, like for example, in the drafting, we used to put the two into and the chamfer details. If the chamfer is at two position, so two into that means two multiply. So in the case of multiply, we use the x there. Okay, we use the x there, like small x or capital X. It depends on the user. To denote what? To denote multiplication. But here, to denote the multiplication, we use the asterisk like this. Okay, this is multiplication, this is divide, and this is power like this. And this will work as if I just put the expression as like this. So the meaning of this is x square, x raised to power 2. We have covered plus, minus, multiplication, division, and then power. So these are some basics. And we also use the sine, cos, that means trigonometry expressions. Okay, I hope the operators are clear to you. Now let's move forward. So here comes x1 and x2. X1 represents the start range of the equation. Like if I am going to put the equation as 10x, hit enter, and you can see it will represent the red color. Why so? Because there is some error with the equation. Like what is the purpose of x? So I have not defined any kind of operator. So the intention is 10 multiplied by x. So put the asterisk here and hit enter. Whenever the equation is going to be get blacked out, that means this is correct. Otherwise, it will represent the equation in red color if there is some problem regarding the equation. Now comes the parameter. The parameter is going to be start from 0 and it will end at the value of 10. Now hit enter. Now here comes the line on the basis of this. So if I just talk about the y, so this is the y direction and 10 into 10 is 100. That means 100. Okay. Now why I am considering this? Just take a note of this that 10 into 10 is 100. I will let you know about this. Just click on OK. Now let's go to the dimension, and from this point to this point in this direction is 100. I hope now why I was mentioning about the 100 is clear to you. If I just go to the equation like this, so the equation will work like this. 10 into 0 is 0, 10 into 1 is 10, 10 into 2 is 20, 10 into 3 is 30. So this will trace all the points up to what value? Up to 10, and it will connect those points. So this is how the line is going to be get traveled along with the points we have mentioned here. I hope the basics of equation is clear to you. Now let's move forward. For that, I'm going to delete this. Just click on yes. Just zoom to all. Now just go to the center line. I'm going to display the center line like here. Okay. And this is going to be as make vertical and just give the dimension just to make it fully defined 220. Now you can see the sketch is fully defined. Now just go to the line and I'm going to have the line like this. Now I'm going to define all the dimensions by which it is going to be as fully defined. So let's do it quick. So now you can see this is fully defined. Now I will let you know the purpose behind doing this. Just go to the equation driven curve and here I'm going to put the equation as 10x plus, again I'm going to have the put the asterisk 10x and this is going to be as plus 20. Okay, now hit the enter. This equation is correct, that's why it is currently getting blacked out. Now this is going to be get start from 10 and the value is going to be end as 30. So here comes the line and I'm going to click on OK. Now I will drag this. Now let's do the dimensioning of this, because here comes a tricky part and I will let you know about that trick. Now if I ask to you that how many dimensions I have used to make it fully defined, 1, 2 and 3, but in the case of normal line 1, 2, 3, 4. So this is the basic difference, like how to define a line using the simple command of line and how to define a line using the equation driven curve, and we have used one less dimension because the other dimension which is here, so that is controlled by the equation. Okay, so this is the how you can use the equation driven curve. Now let me just clear all these sketching part. Going to delete this one and this one. Now come to the general terms, like general equation, like what is the equation of the parabola. If I just go to the equation driven curve, now if I ask to you what is the equation of the parabola, so the equation of parabola is y square equals to 4ax. Okay, y square equals to 4ax and I need that equation in the terms of y, so it will be like y equals to under root 2ax. Let me just open the notepad. So y equals to under root of 4ax. Okay, now I want to have this equation in the mathematical operation. Let a be a equals to 4, so it will be like, if I just come here, so it will be like under root of 16, like 4 into 4 is 4 multiplied by 4 into x, correct, into x. So it will give the as equals to 16 into x, correct. So I have to put this 16 into x, and if I just talk about the SolidWorks or the complete expression of this, so it will be like this bracket. In the bracket we have to put this 16 into x and the power will be like this. For power we have to use this symbol and it will be like 1 by 2. Okay. Just copy this and paste it over here. Hit enter. And the x will start from 0 and it will end to 20. Now here comes the parabola, like here. And if we want to increase it, 60, 100, 200, like this. So this is the equation of the parabola. And if I just put the minus sign here, it will go in the reverse direction. So this is the equation regarding the parabola. Now let's have some more fun regarding this. Like if I just go to the y, so let's have some sine or cos operations like trigonometric operation. So for that you just have to put the value like tan into sine, okay, into asterisk tan into sine x. Hit enter. Now here comes the error. We have to put this in a bracket. And here, now you can see this is done. Okay. So we all know sine 0 starts from 0 and ends at 1. So this is the sine curve which we will get. If I just hit OK, so this is the sine curve. Similarly, we can have the cos curve if I just go to this equation and change this to cos. Hit enter. Now the cos 0 starts from 1, that's why it is here, and this completes the equation regarding the explicit function. Okay, now if you have carefully gone through the observation of the explicit regarding these options, so it would be much easier to understand the parametric. Why so? Because here comes the two equations. Earlier it was like single equation and range. Here comes the two equation and range. Here I am going to start from 0 to 10. Here we have to put the equation of in terms of t. Earlier in the explicit function, we have to put the equation in the terms of x, but here comes the t. So I am going to start this with very basics, like I am going to give it as 0 from 0 to 40 and x is going to be as 10 into t plus 50 into t. And if I just talk about this, so y is going to be the function of t also, though, so then it is going to be 50t and plus 10 into t. So it will give us a straight line. If I just click on zoom to all, a straight line, okay, because the value is near about same, okay, like 1, 1, 2, 2, 3, 3, 4, 4. So it will make a straight line. Now let's have some sine function here. If I just put the value as tan into sine bracket t. Now let's check what will happen. Now you can see this is the equation this is the line we will get by these equations, like you can see here. And what if we use the parabolic equation here, like this, hit enter. So it will give a line like this. Okay, I'm going to increase this as 500. Okay, just decrease it or just eliminate it. Now you can see, just zoom to all. So this is the parabolic equation we will get by these equations. Okay, so this is how we can use the equation driven curve. Now what we have learned in this, just go to the notepad, equation driven curve. Okay, so we have learned about the operators and then what are the explicit, and we have next as parametric. In the parametric, the function is going to be t, and here the function is going to be of x. Okay, and here we have to y in terms of x, so y equals to like 10x, and here comes the x equation, like x equals to 10t and y equals to, if I just press the tab, and y equals to 5t or 20t. Okay, and later on we have some equations like parabola. Then we have the trigonometric functions, trigonometric functions. Okay, and in that we have to put the angle value in the bracket or angle function in the bracket. So this is how we can use the equation driven curve, and we have gone into the very deep of this tutorial, like how to make a spline, how to control the spline, how to add the point on the splines, how to give the dimensions to the handles, how to put the handles, how to simplify the splines. Later on we have covered the Bezier splines like the style splines, which are some advanced part. So you can have you could eliminate that part regarding the Bezier, because that is going to be get into detail on the surfacing. Like in the surfacing, we may have to use the Bezier splines to trace the surface. Okay, next one is the equation driven curve, which is a very most useful tool regarding how to use the equations in terms of the getting the line in the graphics window. So this completes the tutorial of this spline. I hope you have enjoyed the learning of this spline and have gone into the deep dive with me. Please do like, share the video if you like the learnings of these amazing tool, and do not forget to subscribe my channel. Thank you.